tutorial today, we want to begin talking about solving equations. But before I solve our first equation, we need to make sure we know how to check our solutions. And to do that, you need to be able to determine whether a number is a solution to an equation. So to do that, what I'm going to do for problem A is remove the y in this equation. Now you do notice you have an equation over here on the right, 9y plus 2 equals 6y plus 3, because there's an equals in it. If there were no equals, that's called an expression, right? An algebraic expression. Now what we're asked to do is substitute y equals 4/3 everywhere there's a y in the equation. So to make it very clear, I'm going to pick up this 4/3 and I'm going to plug it in right here, and I'm going to plug it in right here. Now, if I get the same answer on each side of the equation, in other words, I get a true statement, then I know that y equals 4/3 is a solution. If I do not get a true statement, then I know y equals 4/3 is not a solution to this algebraic equation. So here we go. I've got 9. Now, when I remove the y, I'm going to replace it with parentheses, and there's my 4/3 plus 2. On the other side, we're really checking to see if this is true. So that's a question mark I have above that equal sign. That's 6 times 4/3 plus 3. Well, now this just turns into an order of operations problem, and we're trying to simplify each side independently. So when I work on the left, I'm not at all worried about what's on the right side of the equal sign. Now remember, to multiply fractions, the first thing would help is if I put that 9 over 1. We know the rule for multiplying fractions is numerator times numerator, denominator times denominator. So you can say that's 36 over 3. But what I like to do is cross-cancel numerator and denominator if I can. So this 3 and this 9, 3 goes into 9 3 times, right? 3 goes into 3 once. So instead, I have a more simplified version of 3 times 4 is 12 in the numerator over 1 times 1 is 1. Remember, when there's a 1 in the denominator, there's no need to write it. 12 over 1 is the same as 12 plus 2. And we know 12 plus 2 is 14. So I have completely simplified the left side. Now let's move over to the right. So once again, I'm multiplying fractions, but then you think that's not a fraction, but I can make it a fraction. And I do notice that this 3 and this 6 have a common factor of 3. So I'm going to say 3 divides into 6 2 times, 3 divides into 3 once, and then I'm going to multiply what I have remaining. So I have 2 times 4 is 8 over 1 times 1 is 1. Remember, we talked about we don't need the 1 in the denominator. The plus 3 comes down. Remember, I don't know if these are really equal, so I'm going to just put my little question mark above it. 8 plus 3 is 11. Well, turns out they're not equal at all, right? Now, what this means is y equals 4/3 is not a solution. Not a solution to the equation above. Now here we go again, question B. Determine whether a number is a solution to an equation. In this case, our number is 7/5, and they want us to plug 7/5 into every y that's in our equation, so here and here. I think it's worth it to take a minute and pause and do this one on your own just to see how it goes. So what I hope you have done is you have 5, and then you have parentheses 7/5 plus 3 is equal to 10 parentheses 7/5 minus 4. Fact is, we don't know if it's equal or not. If in the end this is equal, that means 7/5 is a solution. If it's not equal, that means 7/5 is not a solution. So the next thing we've got going on, just I'm looking at only on the left side right now. I want to completely simplify the left before I move to the right. I'm multiplying fractions, so I need to put that 5 over 1. I also noticed that 5 and 5 had a greatest common factor of 5, which means when they cancel, it just leaves 1s. So I have 1 times 7 is 7 over 1 times 1 is 1. So there's no need to write the 1 in the denominator plus 3, and we know 7 plus 3 is 10. Now let's move to the other side. Okay, now I'm noticing here I still have to multiply fractions way before I can subtract. Okay, so this is 10 over 1. 10 and 5 have a greatest common factor. 5 goes into 5 once, 5 goes into 10 twice. And I have 2 times 7 is 14. That would be over 1, so need to write the 1 in the denominator, bring down the minus 4, and 14 minus 4 is 10. So it turns out that each side is equal when you plug in 7/5. So what does that mean? That means y equals 7/5 is a solution. Now, I would like to spend some time talking about rules for solving equations. And the first rule, and probably the most basic rule, is the subtraction property of equality. So you see I have a scale here, like a balance scale, and I want you to think about this as your equal sign. And since the scale appears to be balanced right now with nothing on the scale, then everything is equal. Well, what if I put weights on it? Well, what I'm going to do is I'm going to put equivalent weight on here. So let's just say we put 10 and we put 20. So we put 30 pounds on the left, and then on the right, to keep it balanced, we do 10 and 20. So we have a 30-pound weight and a 20-pound weight on the right. So here's what we're going to do. Let's subtract. Let's move the 10-pound weight off of the right-hand side. Now, what do you think is going to happen? Well, of course, when we move that 10 pounds off the right-hand side and take it off, then the left-hand side is heavier, and these are not equal anymore. So what would we do to equal them back up? Well, we need to subtract our 10-pound weight off the left-hand side as well. I know it seems silly, but this really has an impact. Whenever you have an equals in your problem, think about it like a scale. The thing that you do to one side, you must also do to the other side. And right now we're talking about subtracting something off one side, so you subtract it off the other side as well. What this does is it makes sure everything remains balanced. So if you would like to subtract 10 from the right side, you are required to also subtract 10 from the left side. Now the property is written above in blue, so if you know A equals B and you want to subtract, say, C, then you have to subtract C on both sides of the equation. As long as you do that, you are following rules of property of equality, and you won't make any mistakes as long as you follow those rules. So let's actually do some problems. Okay, so question C says solve. Now, you notice we have an equal sign. A lot of students, when they first start learning, will draw a line through the equal sign. That's like your scale, okay? Now, your goal is to get the x by itself. It's called isolate. So I want to isolate this x value. Well, right now, what's happening is we're adding 13 to that x. So you want to undo whatever operation is happening to your x value. So to undo addition, we know we would subtract, right? So I have x plus 13 equals 20. I'm going to subtract 13 from the left, just like taking that 10-pound weight off my scale. But if I do that, I also have to take 13 away from the right. All right? So this plus 13 and this minus 13, you see, they cancel each other out. Now, on the left-hand side, you'll notice I still have an x remaining. Okay, so this is, on the left, is living two things, an x and a plus 13. So the x is still on the left. The equals stays lined up. Now, on the right, I have 20, subtract 13. Notice those are like terms, so I can do that subtraction. 20 minus 13 is 7, and there's my solution, x equals 7. Now, what you should always do after you solve and find your solution is to check your work. So checking your work is the same like the first two problems we did. So I am removing the x in our problem right here, and I'm replacing it with our solution right here. So in other words, is 7 plus 13, is that equal to 20? Well, sure it is. 20 is equal to 20, so this checks just fine. And the wonderful news is you can check every one of these solved problems. And when I say check, I don't mean redo it. I mean take your answer and substitute it in and see if it works. So let's try another. So the next problem, x plus 8 equals negative 31. Again, you may want to draw a line through your equals. That's not required, just something students like to do when they first learn how to do algebra problems. Now you want to get the x by itself. You will find that you're not going to do anything with the x. You want to leave the x alone, and you want to remove the other things around the x. So I'm going to subtract 8 because the opposite of adding 8 is subtracting 8. I want to do that on both sides of the equation. Now if you'll notice, this plus 8 and minus 8 cancel each other out. On the left, I'm left with x, and that's the only thing left. Equals stays lined up. Now here we're doing negative 31 minus 8. Now I've got a trick for you I'm going to show you every time. Whenever you're subtracting, you notice that's the same as plus a negative. If you add, no matter what these signs are, if you add the two numbers together in your operation, you take it as a sign. In other words, instead of saying negative 31 minus 8, I say negative 31 plus a negative 8. Then you're saving the trouble of the keep change step. I just always add and take the signs with it. So negative 31 plus negative 8 is a negative. I almost lost my negative 39 because you're adding the same signs, which you keep the sign and add the numbers. So our answer is x is equal to negative 39. Now it doesn't stop there. We should always check. So I'm going to try to check all my answers in green this time. So again, what am I doing? I'm substituting x with my value that I got for x. So I have negative 39 plus 8. Is that really equal to negative 31? And it is. Remember, when you add opposite signs, you actually subtract the numbers and keep the heavier sign. So 39 minus 8 is 31. The heavier one is negative. And I get negative 31 equals negative 31. So that's a check mark. It checks just fine. So my question to you is, how do you think we would solve this type of problem? Notice it's different. I still have an equals. I'm going to put a line down my equals. And you see my variable is b. So I'm going to try to get that b on the left side over here all by itself. So I'm going to do the opposite of subtracting 11, and I'm going to add 11. So if I add 11 on the left, I'm going to add 11 on the right. Is that what you were thinking? If you're minusing, you add. If you're adding, like we did on last problems, you subtract. So what happens now is the minus 11 and the plus 11 cancel. You know, negative 11 plus 11 is just 0, right? So I'm left with b on the left-hand side. The equals comes down, and you have a negative 24 added to a positive 11. Remember, you're adding opposite signs here, which means you really subtract. 24 minus 11 is 13, and you keep the sign of the weightier one, which is the negative guy. So b equals negative 13 is my answer, but I need to check it. Okay, so I'm going to remove the b, and I replace it with negative 13 minus 11. Is that really equal to negative 24? What do you think? Well, this is one of those negative 13 minus 11. You might be good at it in your head, like if you're already $13 in the hole in your bank account and you write an $11 check, you know how much you're not going to have now, right? But if you don't see that, you change subtraction to addition always, and you change the sign of the next number. So essentially what we're doing here is we're adding two negatives, which gives us a bigger negative, and it checks. So why don't you pause it and do the one right next to on F. I know you see what to do. Draw the line. I'm going to add 4 on each side of the equal sign. The negative 4 and the positive 4 cancel, right? That's the whole point. But we still have the y on the left, which is exactly what we want. And 99 plus 4 we know is 103. So y equals 103 is our solution. But we should really check it. So 103 minus 4, is that really equal to 99? You bet. 99 definitely equal to 99. All right, so we're doing well. Okay. Now, I know this looks more challenging, and it probably is, but think about it this way. It's the same idea, right? I've got an equals. I'm going to draw my line down it. Again, not required, but if you're new to this, I think it's worth it. Now, remember what you're trying to do. You're trying to isolate this guy right here. You want him on one side of the equation all by itself. So what am I going to do? Well, if I'm subtracting 3/4, I need to do the opposite and add 3/4. And just like the scale, if you do it on the left side of that line, which is the left side of the equal sign, you're required to do it on the right side as well. And what that does is it keeps your equation balanced. You're just balancing the equation. That's all. So now what happens here? This negative 3/4 cancels with this positive 3/4. And I'm left with exactly what I want to be left with. On the left is an x. Now on the right, I have to add 1/5 to 3/4. Now can we do that as is? No. Okay? You need to know how to find a common denominator. Even if you have a calculator right now that will let you find a common denominator, or do the fractions itself, you are doing yourself a disservice, because when you learn how to work with rational expressions and add and subtract, you still have to know how to find a common denominator. So please promise me you will focus on doing these yourself. If you have the fancy calculator, check yourself. That's fine. But please do these. Now, I need a number that both 4 and 5 divide evenly into. Remember, again, I can't add these together because they have different denominators. Multiplying and dividing is fine with different denominators, not adding and subtracting. So what am I going to use? 20, right? And I'm just going to write it right out to the side of it since I have the space. Now, what did I multiply 4 by to make it a 20? It's a 5, right? So that means I have to multiply by 5 in the numerator and the denominator. So that's going to be 3 times 5 is 15 over 20. Now, at the top, the 1/5, I multiplied 5 by 4 to get 20. So I have to multiply the 1 by 4 also. 1 by 4 is 20. So instead of adding 1/5 and 3/4 together, I'm going to add 20. Ooh, I did that wrong. Let me check my work. 1 times 4 is 4. Okay, there we go. So instead of adding 1/5 plus 3/4, I'm going to add 4/20 plus 15/20, which is going to give us 19 over 20. That's my solution. I'm circling it, possibly prematurely because it's got a check. So let's check it. So I'm removing the x in my original problem. I'm replacing it with my answer. There's still a minus 3/4 here. Equals 1/5. The question is that really true? Is 19 over 20 minus 3/4 equal to 1/5? Once again, not allowed to subtract this right here until I have a common denominator. So to make this 4 a 20, I'm going to multiply by 5 over 5. Okay, so that gives me 19 over 20 minus 15 over 20. Let's keep simplifying that, okay? I'm running out of room, so I'm going to go to the right. 19 minus 15 is 4 over 20. Now that reduces. You can divide that by 4 and divide that guy by 4, which is 1/5. So it checks. Checking these fractions problems is not as fun. I know, because you're dealing with fractions. Yet probably the most important ones to check, because that's where people make the most mistakes. So on the next problem, right? I'm trying to, again, remind yourself what you're trying to do. You're trying to get that y by itself on one side. So to get rid of that plus 5/7 that's out beside it, I'm going to subtract 5/7. Not just on the left, but on the left and the right. Just like my scales, they have to stay balanced. 5/7 minus 5/7 cancels. I still have a y. My equals remains in the middle. You always keep your equals lined up. Now, I cannot do the operation 2/3 minus 5/7 the way it is. So I'm going to find a common denominator. Now, I need a number that both 3 and 7 divide into evenly, and that number is 21. What do I multiply 3 by on the top here to make it a 21? 7. So multiply 7 both in the numerator and denominator. That gives me 14. On the bottom fraction, negative 5/7, I multiply 7 by 3 to make it a 21, so I multiply the numerator by 3 as well. That makes that, careful, don't lose the negative 15. Positive 14, remember, plus a negative 15 is a negative 1 over 21, and there's my solution. Now to check it, I've got negative 1 over 21 for my y, plus 5/7. Is that equal to 2/3? That is the real question, right? I need a common denominator to add these two fractions together. The common denominator is 21, so I'm going to multiply the second fraction of 5/7 by 3 over 3. That gives me negative 1 over 21 plus 15 over 21, which gives me a negative 1 added to a positive 15 is 14 over 21. These can both, each numerator and denominator, be divided by 7, which will give me 2 over 3, so it checks out. Okay? Now, if you need to pause and go back over those, the best thing to do is work them out yourself, and then go back and look at these solutions to make sure that you're either doing it right, hopefully so, or if you make a mistake, you can go, oh, well, I just multiplied and got my common denominator wrong, or something like that. So do it yourself. Make sure you understand. All right, here we go again. Solve. Now this time, maybe strikes a little less fear in you. We're dealing with decimals instead of fractions, and that's perfectly okay. In a later video, I'm going to give you a method to help you handle fraction problems and decimal problems a little easier. But right now, I'm going to go ahead and give them to you and focus on the property of equality we're using. In other words, this is an equation. So I'm trying to isolate this b. What do I need to do to get the left-hand side where it only has a b? Well, I need to do the opposite of what's happening. So I'm going to add 0.52 on the left, which means I have to add 0.52 on the right as well. Now the negative 0.52 and the positive 0.52 cancel, so there's a b only left on the left-hand side, which is my goal. You have to have nothing but your variable. Then on the right, I have to add negative 3.1 plus 0.52. Now again, you talk about the lazy way of reading this. This is negative 3 1/10 plus 52 hundredths, right? I don't mind you saying the points at all. I just want you to realize what's really going on. But I'm adding a positive and a negative, which really means I subtract. I do 0.52 minus 3.1. Oh, I said that backwards. 3.1 minus 0.52. And you keep the sign of the heavier one, which negative 3.1. 3.1 is a bigger number than 0.52, right? So when I subtracted, I got 2.58. But the negative one is bigger, so negative 2.58 should be my solution. And to check it, again, we've been checking in green. So to check, I just take my answer and plug it in for B. Negative 2.58 minus 0.52 is that negative 3.1. Now this is a keep, change problem, okay, because you're subtracting, so that's what's happening. So basically, in my calculator, I'm going to add 2.58 plus 0.52, which gives me 3.1. But really, that's negative because I'm adding two negative numbers together, so it checks out just fine. Now, if you had to do that work on paper, if you had no calculator, you would just line up the 2.58 and 0.52, line up those decimals, add down, carry when necessary, and you will still get 3.1, and then we know it's negative because you're adding two negative numbers together. Try the second one, J, on your own and see how it goes. What I hope you're doing is drawing a line if you're new to this. I'm trying to get the C by itself. It's called isolating the C. To do that, I'm going to subtract 1.5 from both sides of the equation. Those cancel, so I'm left with C equals 2 minus 1.5 is 0.5. A lot of you can just see that in your head, or you can use a calculator. So my solution is C equals 0.5. Now to check it, I have 0.5 plus 1.5. Does that really equal 2? Again, if you're using a calculator, you will see quickly that that does equal 2. It checks out fine. If you're not, you would line up these decimals. I typically put the bigger number on top when I'm adding. Okay. And then 5 plus 5 is 10, so 0, carry the 1. The decimal comes down directly. 1 plus 1 is 2. And there's your check, all by hand. All right, let's take a look at this problem. It looks huge compared to what we've been doing, correct? So I see that it's an equals, So I'm going to draw my line. Remember, I have to, whenever, this is my scale. I've got all this stuff on the left and this little old negative 14 on the right. Now here's something I want you to always keep in mind when solving equations. Each side must be simplified first. In a future video, I'm going to give you some guidelines for more complicated equations. It's coming up real soon. But that's one of them. Each side must be simplified first. So before we do anything, let's take a look at this. I've got 11y and a like term over here of a minus 10y. Let's think about this. 11y minus 10y. What would that be? Well, that would just be 1y, right? 11 minus 10 is 1, and you keep the like term. That's 1y. And then I've also got like terms right here. The negative 4 and the negative 8. We can combine those together. The easiest way to think about that is to put a plus in your mind. Negative 4 plus a negative 8 is a negative 12, so I could put minus 12. And then the equals negative 14 is still true. Now 1y we know is just y, so I could even write it one more time. And it turns out this really complicated problem that we have on the first line turns into a not bad problem at all on the third line. So we're trying to get that y by itself on the third line. So what do? Well, I extend my equation line. I got to get rid of this minus 12. So now I'm going to add 12 to the right and add 12 to the left. The minus 12s cancel and I get y is equal to, now I'm taking a negative 14 and adding 12, which we all know is negative 2, right? We're adding opposite signs. We subtract the numbers. 14 minus 12 is 2. The heavier number is negative, so we made it negative 2. Now, keep in mind, I'm supposed to check this. We go to the top of the page to check it. So I have 11. I'm supposed to remove my y and put in negative 2 minus 4 minus 10 times negative 2 minus 8 equals negative 14. Now, are you wondering why I didn't just go to the third line and check it? Why didn't I just check it here? Well, remember, when you check something, you're checking your work. And when you're checking your work, you could have made a mistake in line 1 or line 2. So you need to go back to the original to check your work. That is my advice. And now you know how to do this. This is order of operations. I must multiply here and here before I can add. So 11 times negative 2 is negative 22. I'm recopying the minus 4. Negative 10 times negative 2 is positive 20. And I'm recopying the minus 8. Question is that really equal to negative 14? That's what we're trying to figure out. Now, got some keep change going on here because this is subtraction. I'm going to write it as plus a negative. This is subtraction. Write it as plus a negative. I have negative 22 plus a negative 4 is negative 26. Negative 26 plus 20 is negative 6. Negative 6 plus a negative 8 is negative 14. That does equal negative 14, so it checks out just fine. Well, what about a problem like this? What should we do? Well, again, keep in mind, you must simplify each side first. So it's definitely an equation, but there's work that can be done on the left. Nothing we can do on the right. Negative 22 is as good as that gets. What can we do on the left is use what we call the distributive property. Remember that? So I do 7 times x is 7x. I also have to multiply 7 times negative 5. That's a negative 35. The negative 6x outside of the parentheses, I just bring it down, and I'm recopying the negative 22. Now I'm not finished. I have like terms. I have a negative 7x, a positive 7x, excuse me, and a minus 6x. Those are like terms. Now, 7x minus 6x we know is 1x, and then minus 35 I'm just recopying equals negative 22. Now, why did I put the x in the front? You could have written it as negative 35 plus x. But 1x minus 35 is the same thing. Now the 1x, we could just write it as x minus 35 is equal to negative 22. You can always do that when you have a 1 coefficient. Finally, this is simplified. I'm ready to solve. So I have my line for my equation. To get the x isolated, I'm going to do the opposite and add 35 to both sides of my equation. The minus 35 and the plus 35 cancel, and I'm left with x on the left. Now on the right, I'm adding a negative number to a positive, which really means we subtract. So when you do 35 minus 22, you should get 13. And the larger number is positive, so this would be positive 13 is my solution. But I'd be fool if I didn't check it, so I'm going to. That's 7 times 13 minus 5 minus 6 times 13. Is that really equal to negative 22? That's the question. Now here you do not have to use the distributive property because we know what 13 minus 5 is. That's 8. Okay, and then 6 times 13, still looking to see if that's negative 22. Now feel free to use your calculator here, y'all. 7 times 8 is 56. Have to multiply here as well. 6 times 13 is 78. And then when you subtract 56 minus 78, you do get a negative 22, so it checks out. So I know this answer is correct. I think it's worth your time and learning to pause it and work through this problem. So what do we need to do first? Well, we definitely need to distribute the 3 inside the parentheses here. Also, you need to distribute that. Think about this as a negative 5. Go ahead and take that minus with it. We talked about that when we worked on the distributive property. If you're having trouble with this, go back and find the video on properties of real numbers, the distributive property. So 3 times 2x, and you could even write that down, 3 times 2x, and then minus 3 times 7. And then minus 5 times x minus 5 times 4 equals negative 10. Now to me, I find it better to do that in my head, like 3 times 2x is 6x. And 3 times 7, negative 7, is negative 21. And negative 5 times x is negative 5x. And negative 5 times positive 4 is minus 20 equals negative 10. But we still have like terms to combine together. I got a 6x and a minus 5x on the left. And I also have a negative 21 that I'm going to add to a negative 20. Again, I know those are subtraction signs, but you can take it as a negative 21 and a negative 20, and it saves you a lot of detail work dealing with keep, change, using properties of subtraction. Okay, so 6x minus 5x, we know that is just x. It's 1x, which is x. Negative 20 plus a negative 21 plus, remember I'm saying plus in between, a negative 20 is negative 41, and that equals negative 10. Now, not only till now is it time to solve. So I draw my line. I'm trying to get this x alone, so I add 41 and I add 41. Those cancel. On the left I'm left with x. And I'm adding a negative 10 and a positive 41. So really we subtract the two numbers. 41 minus 10 is 31. The larger one, 41, is positive, so my answer is positive. Now to check it, 3 parentheses 2 times 31 minus 7, close out the parentheses, minus 5, and then 31 plus 4. Equals negative 10. We're trying to see if this is true. So I'm going to work in the parentheses first. I'm going to do a few steps in my head. Like first I'm going to do 2 times 31. We know that's 62. And then I do 62 subtract 7 is 55. Minus 5, and then in parentheses I have 3 plus 4 is 35. Then I multiply 3 times 55. And I get 165 here, minus 5 times 35. So I'm subtracting 175, and 165 minus 175 is negative 10. If you're having trouble with the checks, you need to go back to order of operations problems. That's what's happening. We did a lot of that early on in the semester. What we have here is a large problem. Let's work this out together. It does have something a little extra we haven't dealt with just yet, and there's a future section we'll deal with this more. But I'm looking at each side separately, like on the left. You see this set of parentheses? Remember, when you have a number right by a set of parentheses, then you use the distributive property. So I'm going to multiply 7 times 3x and 7 times negative 1. Let's go ahead and do that. 7 times 3x we know is 21x. Then 7 times the negative 1, you can say that's minus 7. Now I'm going to multiply this negative 4 times 3x in the parentheses and negative 4 times negative 2. So negative 4 times 3x is negative 12x. And then negative 4 times negative 2 is plus 8. You know, a negative times a negative is a positive. Now, on the other side of the equal sign, on the right side, I got to do the same thing because, again, this is multiplication, and I cannot combine x and minus 2 together because I don't know what x is. X is a variable. They're not like terms. So I have to use the distributive property. 8 times x is 8x, and 8 times negative 2 is minus 10. Now, the next issue I have is I'm trying to completely simplify the left-hand side. I have a 21x and a minus 12x. I need to combine together, right? We know 21 minus 12 is 9. So that's 9, and I keep the x. I also have a negative 7 that I need to combine together with a positive 8. Negative 7 plus 8 is plus 1. Now, we do have each side completely simplified. You see that? So 9x plus 1 and 8x, I can't combine these together because this has an x in it and this doesn't, and they're not like terms. Same thing on the right. Now, this is the first problem that we've run into when we have variables on both sides. Notice there's an x on the left and there's an x on the right. And really, this shows up in a later section, but I wanted to go ahead and throw these out at you. What you need to do is get all the variables on the same side. So to do that, what I'm going to do is I have choices. I can either minus 8x on both sides or I can minus 9x. Why minus 8x? The 8 and the x, okay? Because 8x minus 8x makes it gone. It's not on the right side anymore, and 9x minus 8x is 1x. Now, had I subtracted 9x, I'd have a negative, and we haven't done that yet. So I'm going to subtract the smaller of the two. It's easier. There's still a plus 1 we write over here. Now, on the right, I only have a minus 10 left. Now, finally, we're where we were in the beginning, okay? I need to get this x by itself. So right now, there's a plus 1 sitting next to it. To get rid of that plus 1, I'm going to minus 1 on the left and also minus 1 on the right. Okay, remember that big line is right there. Now, 1 minus 1 is gone. I'm left with x only on the left. And then negative 10 minus 1, another way you could say this is negative 10 plus a negative 1 is going to give me negative 11. The color didn't change. Negative 11 is my final solution. Now, for time's sake, I'm not going to check this one. It's just a time issue. I do always recommend you checking your work, especially on a test, to make sure you've got the correct answer. That last problem was so big that I made sure we had 2 of these we could take a look at. It's probably worth pausing this one and trying it on your own. But you see, first of all, we need to use the distributive property. Why? Whenever you have a number or a negative sitting right next to parentheses, you're going to have to multiply. Now, if I knew what this was inside, like if that just said 3 minus 1, I'd say 2. But because it says 3x, I cannot combine these together. So distributes, all I can do, 3 times 3x is 9x, right? And 3 times negative 1, think about that as a negative 1, is negative 3. Then on the other side, 3 times 4x is 12x. And then 3 times a positive 5 is plus 15. And then I have negative 4 times x is negative 4x. And then negative 4 times negative 7 is plus 28. Now again, if you're still getting hung up on the fact that that's a minus 4, it's not a negative 4, you're right. The reason I'm saying it's a negative 4 is because we can say this is using the rule for subtracting integers. This is a keep, change, change. So I'm changing my subtraction to addition and changing the sign of the next number. You see that? And so it's okay to say that a minus really is just a negative of that number. Now over here on the right, I've got like terms. I've got a 12x I want to combine to a negative 4x. And what is 12x plus a negative 4x? Well, it's 8x. And I also have a positive 15 and a positive 28 to combine together. And that's going to give me 28, 38, 43, right? Did you hear that in my head math? Okay, so 9x minus 3 on the left equals 8x plus 43 on the right. So all we've done is stuff that you knew how to do before we even got to this module, which is use the distributive property, combine like terms. Finally, we're at a place where we're actually solving. So now is where we start to solve. Well, to do that, I must have all my x's on the same side of the equation. So I have a choice, either subtract 9x or subtract 8x. I'm going to subtract the smaller of the two to avoid negative numbers. Notice I'm doing it on both sides to keep it balanced. 8x minus 8x is gone. That leaves me with 43 on the right, and that's it. 9x minus 8x is 1x. I'm just going to put x. Don't forget to pull down the minus 3. To remember, your goal is to leave this single x alone and get rid of the minus 3. So what am I going to do? I'm going to add 3 on the left and add 3 on the right. That gives me x is equal to 46. And that is my solution. Okay, let's do something new. So we're supposed to translate to an algebraic equation and then solve. We're already used to this translating stuff too. We had a whole section on translating algebraic phrases. So 11 more than b. How would we write that? Well, 11 more than something just means we add 11 to that thing, right? So this would be b, goodness gracious, let me try this again. Sorry for that. This would be b plus 11 is equal to, notice it says it right there, 45. There we go, right in front of us, 11 more than b, which means b plus 11 equals 45. Now, how do we solve this equation? First of all, make sure each side is completely simplified. Done, right? I'm trying to get the b all by itself, so I got to get rid of plus 11. To do that, I'm going to minus 11. So my scale falls on the right, and I'm going to minus 11 over here. All right, so I'm left with b on the left, and 45 minus 11 is 34, correct? And you could take that 34 and plug it right back in there. 34 plus 11 is 45. It checks out. All right, let's try the next one. 27 less than y. First of all, how are we going to write that? 27 less than y. That means we're subtracting 27 from something, and that something is y. So it's y minus 27. It says is equal to negative 2. You read it just like it says it. You're not writing this in the same order, though, because it says 27 less than y. That means we subtract 27 from y. Now, again, I draw my line through my equal sign. I'm trying to get this y on the left all by himself over there, so I got to get rid of the minus 27. Well, to eliminate minus 27, I do the opposite and add 27. But just like the scale says, if I add 27 on the left side, that's going to drop right down. So I have to add 27 on the right side as well to keep the whole equation balanced. The negative 27 and plus 27 cancel to give me y equals. And now I'm adding a negative 2 plus 27, which is 25. And again, you could check that. If I do 25 minus 27, that's going to equal negative 2, isn't it? So it checks out just fine. Okay, so last one of these guys, and we can call this video done. The difference of 3x and 2x. What does difference mean? Subtract. Yeah, you got it. Okay, so the difference of those means I subtract those two. Does it matter what order? Well, it does, because difference is subtraction, and subtraction is not commutative. But you always write it when it says difference in exactly the order that it's given. So 3x minus 2x is equal to, it says is, so that means equal to 17. All right, well, this is one of those we need to simplify both sides first. So 3x minus 2x, you work with the coefficients, which is 3 and 2. 3 minus 2 is 1x is equal to 17. We talked about how that 1 doesn't matter. It means the same thing as just x alone. So x equals 17. What do we do to both sides? Not a thing, because the x is already isolated. That is our answer. So the difference of 3x and 2x is 17, means x is 17. So 3 times 17 minus 2 times 17 is definitely equal to 17. You could plug it right back in there and check it. But I'm going to go ahead and let you go since I'm 45 minutes in. You have a wonderful day.